Hello student, this is Yashadari. In this video we know about the Weiler Atherton algorithm. This is used to clip the polygon. Let's start. So Weiler Atherton is another method or algorithm which is used to clip the polygon. We know about the what is a convex and concave polygon and how we have to clip in the using the Sutherland-Hodgman clipping algorithm we covered in a last video. So if you have the doubts means you have to watch what that video and come back to the this video for how the concave polygons will be clipped. Okay. So what is the drawback or limitations of a Sutherland-Hodgman is whenever we are to clipping the polygon edges with a clipped boundary, the edge will be appear with the polygon, the boundary of a clipped window, right? Means here if we clipped as a left, right, top, bottom. So this AB edge will be not removed completely. It will pass through here. So clipped these edges means it will show with the connected with this clipping window. So to avoid this one, we used a Weiler Atherton algorithm. How this Weiler Atherton will be overcome this effect we will see in this video. Okay. So this is a drawback of or a limitations of your Sutherland-Hodgman clipping and it is suitable to the convex. What is a convex meaning? The polygon which is appear within the window. Means this is your polygon and it will come in within the clipping window, that is a convex. Means the pixel will be inside the window and we want to draw a line. The line will be appear within the a clipping window, right? The angle of this line or a polygon is less than 180 degree for a convex, right? So concave is a angle will be um, any one angle of the given polygon is greater than 180 degree. So this is about the convex and concave polygon. We clipping use the Sutherland-Hodgman. We know about how it will clipping, right? Now we will focus on a Weiler Atherton algorithm. So basically here we maintaining a two tables, or you can say that is name given as a subject polygon and the clipping region, that is called a clip polygon. This is a two columns we are maintaining with the help of the given polygon. Okay. So what is the subject polygon? Subject polygon nothing but a given polygon, that is called a subject. In this we have to take in the all the vertices and edges of the given polygon. And clip polygon means whatever the edges will entering. Here they are maintaining the starting and ending of a particular edge. We maintain it will the subject polygon maintaining the all the edges or vertices in the clockwise direction. If are outside the window or outside the clipping window, we take the in a clockwise direction. We maintaining the table. So while here they give the exterior boundary vertices of the polygon are described clockwise. Means we are maintaining the clockwise direction. We taking the edges value vertices, while interior boundary vertices or holes are described counterclockwise. Okay. So for this example, the CD A B C D E F G H, this like this we are taking the, and see in detail we will see the what are the how the algorithm will be performed. So algorithm is first step to determine the intersection of the subjects. Means for the whatever the given polygon will be taken as a subject. Once this is your given clipping window size, means this line will be, sorry, if the line is entering, means this edge is there. So here we are taking the intersection point, right? As a subject will be edges of AB. This is a entering, right? The this is a edge will be entering to the windows, but we are taking as a intersection as a starting point, and end will be your B vertex. So here we are taking a three values, that is a vertices of a polygon and intersections and a clipping windows as a C1, C2, C3, C4. Okay, like this. Next, the process non-intersecting polygon borders are established holding the list. Means we are taking all the edges with the clockwise direction with the intersection and vertices, right? So what is the next step? Create two disjoint intersection vertices list. First one is entering list and leaving list. Means here AB edge is there. It will AB edge will be entering to the where it is entering with the intersection of I1. I am giving a intersection as I1. This is your entry part. Edge will be start with entering a window with this and end with the your B edge. Like this we have to maintain that table. Now perform actual clipping against clip polygon to obtain clip polygon. First we have to remove an intersection vertex from the entering list. Next, follow the subject polygon vertices list until an intersection is found. Please go through the points. We will discuss it with the example. We clearly getting these points. Okay. Follow the subject polygon vertex list until an intersection is found. Okay. Next, using the link, jump to the clip polygon vertex list. Then follow the clip polygon vertex until an intersection is found. Means it will copy the polygon to holding a list. So I know what is happening we are not getting now, but with the figure we can easily understand what is happening here. So how this algorithm will performing. Next, jump to the source polygon vertex list. Repeat until the starting point is again reached. At this point, new inside polygon has been close to the polygon. So let's start with the actual algorithm, how it perform with an example. Okay. So consider the subject polygon with the vertices A, B, C, D, E, F given. Show a step-by-step clipping using Weiler Atherton algorithm. So here they get given as a subject polygon vertices. This is your given polygon with the vertices and intersections. So what is the first step? In first step we have to take the list of the subject polygons vertices which are entering into the clipping window, right? So here first is subject polygon and clip polygon, two columns are ready. Okay, first here where it starts, the polygon will start with the V1, V2, right? So we have to write down in a subject polygon as a clockwise direction V1, V2, then this edge will be going V3, right? So in middle it having a intersection point that I have assigned with the I1. Okay, here V1, V2, I1, V3, V4. Here again intersection is a I2, V5, I3, V6 and I4. This is your a subject polygon. How the polygon will be moving? We are taking the outer vertex as a clockwise direction. So that's why V1 is starting point and V2, then polygon going to V3 with the intersection of our clip polygon is I1, V4, I2, V5, I3, V6 and I4. This is your subject polygon. Whatever the vertices they are given, we have to take in the subject polygon with the intersection, right? Now move on to the clip polygon. How we have to take this one? Clip polygon means here, this part, the clipping window. Blue line will be defining the clipping window. So now go to the first one is C1, next I4, I3, I2, I1, C2, C3 and C4. This is your polygon, clip polygon. Okay. So how we are taking? In a clockwise direction, C1, I4, I3, I2, I1, C2, C3, C4, right? So what is the next procedure? What we have to say? First we have to identify which edge is entering into the clipping. We ignoring V1 and V2 edge. Why? It is completely outside the window. So for that we are neglecting this V1 V2 edge. Now focus on to V2 and V3. Here the edge will be entering, but V2 is not a starting point. Why? Because here the intersection is there. I1 means I1 you have to make a starting point. Then I1, this is starting. V3 is your ending, right? For this edge. Next V3, V4 is completely inside, so we have to take that on and move on to the I2. Here intersection, V5 we ignoring. Here is the end, right? This is the starting and this is end. So we have to make this in a subject one. I1 is a starting. Okay. Now where we will stop? The edge will be entering here and it will end with here because the intersection will be done. Okay. So I1 to I2. Here the starting is I1, V3, V4 and I2. Here it is ending. Now move on to this will where in a the I2 will be appearing in a clipping window. We have to jump on that. Okay, I2, then move on to this starting point. So where is that? I have to make this arrow. So this is how it will clip these edges, right? This much edge. Only this is loop will be there. So for this we not continue with this any edge, right? It will be just closing the V1 to V2. Here loop is there, right? Now come to the next one. Here which one is the entering point? Here I3 is the entering point, V6, V4. Okay. So now for the next clipping, where they start? That is starting in a I3, right? V6, right? V6 and V4. It will end this edge. Okay. Now check into the clipping window. Where is that? I4. Here I4 is there, right? We jumping to the clipping window I4 and move on to the I3, right? This is where closing this. This is how the Weiler Atherton will be working. It's so simple, and main thing is you have to maintaining this subject polygon and the clipping polygon. When check out the intersection point where the which edge will be entering in the clipping window, so we have to take it as a starting point and remaining vertices are continue where it will be ending, right? Start and end point we have to initialize in a subject polygon, and between all the vertices we have to take the and move on to we have to jump into the clipping polygon where the edge will be ended and with the starting, right? So like this it will clipping the polygon. So even after the all the operations run means the algorithm process will done, we will get the result as like this. So there is no extra edges or edges will be appearing. Here just we are looping this. This is how the clip will be done with the Weiler Atherton, that is a convex polygon will be easily clipped. Okay, I hope the concept is clear to everyone. Okay, thank you.